do a quick walk down memory lane here. So one of the first things we talked about in the series was when we have circles. Let's see if this will start working, or is it gone on the blink here? Oh, it's misbehaving. So there we go. So if you have a circle, you always have things called radii inside circles. And if you join two radii together, you get triangles where the base angles of the triangle are equal to each other. So you're always going to have these isosceles triangles when you have a circle and you have radii. So that's like point one. The other thing we learned about was if you have a diameter, or a diameter makes a semicircle, it cuts the circle in half. If you subtend an angle at the circumference, and subtend is a fancy way of saying is the base on which we build an angle. If you subtend an angle at the circumference, it will always be 90. So look at that. I'm moving the angle around, and as long as I have a diameter, it will give 90. If I move this off the diameter, so let's see if I can do that. The moment I move that line that it's no longer a diameter, the angle that's subtended will no longer be 90. Whereas the moment, let's see if I can move it back. Let's see, there we go. We have that. So that's another theorem that or fact we learned about. And then we spent a whole lesson on this next one. Maybe somebody could come online and just explain this one quickly. Like, what is this drawing saying? Who would like to just give us a little explanation of what's going on here? Just as a quick recap. Who feels like, oh, sorry, guys,
We have a hand from Peter, Mr. Eves.
Let's unmute there. Yeah, Pateko, what do you think? What's going on here?
Okay, so the angle at E will always be double the angle at A.
Okay, well, the angle at A, yes. So if you have a common arc or a common chord, and you make, or the fancy word is subtend an angle at the center, if that's 100, the angle subtended from the same arc at the circumference will be half that. So just to show you, like, even if it goes like this, you can see the angle A is 100, E is 50. And then if I go back to here, we still see the angle subtended at the center is double the angle at the circumference. And we even did a shape like this once, where we spoke about where the arc switches over, and this is the angle at the center, and then this one is 130. So that one we did a whole lesson on. So for those who are new, go back and you will see that lesson. And that's a very useful theorem, in general in this section. Okay, then the last lesson, what was we gave this theorem a bit of this fact about circles, a bit of a special name. What was the special name that we gave this this fact, or this theorem about circles and stuff? So Sinosipo Irene Arisiwe said it's the butterfly theorem. Yes. And the butterfly theorem works whether the one wing is bigger than the other, or whether they're about the same size. And what it's saying is, if you have a common arc and you make an angle at the circumference, if you use the same arc and you make another angle at the circumference, they're going to be the same. So that is angles in the same segment, or angles on the same arc. There's two different ways of saying it, but that shape often comes up. The important thing, though, is not any butterfly has this property. There's something special about this butterfly. Who would like to tell me what is special about this butterfly that makes it have this property? Who's feeling lucky, or who feels like they know? What, if I just draw a butterfly shape or bow tie shape, these angles won't automatically be equal. No, that's not true. That is only true in a particular situation. It's the arc, yes, it's the arc. But so basically these 4 points should all lie on the circumference of the circle. So that is on the one, this one over here, that one over there, that one over there. These are all on the circumference of the circle. So the butterfly has to be enclosed in a circle. And then the arc has to be the same, yes. So that's an important idea. It makes sense. I'm not sure if this can leave the circle to show you how it will change, but yeah, that gives you that. Okay, one more last little bit of revision. Just want to do some vocabulary. What do we call this line over here? What's the special name for that line in terms of circle geometry? We give it a special name. Okay. Of course, he's Owetu, Lisango, Tindai all agree it's the tangent. I agree with you guys completely. What about this line? What is this line called? Okay, so that's called a radius. And what is this line called? So that is called a chord because it's not going through the center of the circle. If the chord was going through the center, so if the chord was doing this, then it would be a special type of chord. Last question, what is this special type of chord called? If it goes through the center of the circle. Yeah, it's called the diameter. Okay, fantastic. So that's a bit of vocab. We're just getting familiar with this world of circle geometry, and it's good to know the words that go with it. Let's do one more little bit of vocab. So which one is a segment? Aha. Okay. Ipeleng has asked, in the previous lesson, I spoke a little bit about something called a segment. So if you have a circle and then a chord, okay, a chord breaks up a circle into the major segment, which is the big area there, and then the area, so that's called the major segment. All the area above the chord and all the area below the chord is called the minor segment. So the chord kind of creates the barrier so the segment can kind of exist. So that is good. Then in the previous lesson, I started to talk about something called a cyclic quad. So I've got 4 different types of quadrilaterals here. And these 2, so this one over here and this one over here are cyclic quads. This one here and this one here is not a cyclic quad. Would anybody be able to tell me why? Let's choose to focus on this one. Why is this PQ or PSTQ not a cyclic quad? Who would like to, let's go to Ipeleng. What makes this not a cyclic quad?
So I think it's because point T is not on the circumference of the circle.
Yo, so good, so good, exactly. T is being badly behaved. T is being badly behaved, and it's not on the circumference. Therefore, it's not a cyclic quad. If T was, then all 4 points will be on the circumference. It'll be a cyclic quad. Yes, fantastic. You guys know your stuff. You know your stuff. Okay, so what is today's lesson all about? We've done the review part. Today's lesson is about cyclic quads. So here's the first little bit about cyclic quads. See if you can notice what's a little bit special about cyclic quads. So I'm going to drag these points around, and you'll see some angles are red and some angles are green. And what do you notice about the red angles and the green angles? You can put it in the chat, or you can raise your hand if you feel like you're willing to share. This is a cyclic quad. I see my 4 points. What is special about this? Well, the red angles don't change, but let's move them. Let's move this along. I'll move this to, oh, you're right, the red angles aren't changing. I don't know why that's, they're all fixed. Good, well spotted. Oh no, they're changing. Ipeleng, let's go to you again. What do you think, what do you observe here?
So when I added the green angles, 86 plus 94, it gives me 180. And the theorem says opposite angles of a cyclic quad is equal to 180. Same with the red angles, it's also equal to 180.
Perfect. Okay, so you see 94 and 86 form a pair and they add up to 180. And then on the other side, 76 and 104. And these two pairs are called interior opposite angles. So the interior opposite angles of a cyclic quad, so not any quadrilateral. Hey, this is a very special type of quadrilateral. It fits in a circle exactly. The interior opposite angles add up to 180, or sometimes we say they're supplementary. So this is a new idea that we're going to explore today. In what type of questions can we use this in? Give me a thumbs up if the idea makes sense. Thumbs down if you feel a bit unsure what I'm saying. All right, fantastic. I think that was, yeah. So you basically take the idea of a cyclic quad and you have these pairs of angles. Okay, so all I'm saying is if you've got a cyclic quad, I can't draw on this, let me draw below it. So if you've got a cyclic quad, what is a cyclic quad? Well, it's a quadrilateral which has 4 points on the circumference. So here I have, oh, sorry, that wasn't a very good drawing and it should be straight lines. You'll forgive me. This one and this one must add up to 180, and this one and the green and the blue add up to 180. They're not equal, but together they add up to 180, or we say they're supplementary. So it's almost like these are both interior opposite pairs, and then those ones. Okay, so you'll see it in the question now and it'll make a bit more sense. But before we do that, there's one other theorem that we also need to know about. And then that's the only new stuff for tonight, that we're going to use it as we go. So, okay, I'm dragging that out. That doesn't change. Okay, I'm moving this. Take a moment to look at this picture and what do you notice about this cyclic quad, and which I think focusing on the green may be a good idea. What do you notice about this animation? This is an animation showing all possible kind of angles with a cyclic quad, and I'm seeing Fateko has said the green doesn't change. Yenzi has said the same on both angle sides. Okay. The green angles have the same digits. Yeah, so it seems to me like it's 98, 98. Let's move this. So it stayed like that. What if I do this? Okay. So even if I move the blue one, it looks like this relationship is pretty solid, huh? So to me, how would I describe this in words? Well, what I would say, oh, someone said it even better, or where to? The exterior angle of a cyclic quad is equal to the interior opposite. So when you have a cyclic quad, you'll have an exterior angle, and that's equal to the interior opposite. Let me do my own little impression to help you here. So here is my cyclic quad. So here's the cyclic quad. Now, at the moment, I don't have an exterior angle. So I'm just going to extend that line to give me an exterior angle. Now, this picture is showing me that that angle there is equal to that angle there. And what's more, I could even make an exterior angle on this side. And then that one would be equal to this one over here. And this is called the this is called the exterior angle theorem. In the last lesson of the series, I will talk a little bit more about reasons, but my experience is with this section is it's much more important to get the visual intuition of what's going on. And then the lesson, I mean, the names of the theorems, you kind of just add on once you've got the visual thinking down. Okay. Otherwise, my experience is that students get a bit overwhelmed by all the stuff they have to do at once. And so that's why I'm deliberately leaving out reasons for now. Okay. Give me a thumbs up if the exterior angle equaling the interior opposite makes sense to you. And thumbs down if you feel confused. Fateko, I'm going to come to you now. I see your hand is up. What's your question?
So I was asking, what is the relationship between the blue angles?
Okay. So the blue angles are interior opposites, and the interior opposites in a cyclic quad add up to 180. So 112 plus 68 is 180, and 82 plus 98. These are just, this is really the previous theorem. Okay, let's go to Ipeleng.
Sir, at 112 plus 82 must give you the exterior angle, which is 112, or am I not understanding?
So what you do is you look, the 112 is the exterior angle, right? So it's this one out here. Okay. And then the interior opposite is, if you go from the 112, you go inside and across. So that's called the interior opposite.
With the 82 at the bottom.
Okay, so if there was, okay, I'm going to try and draw this so you can see that 82 would be equal to, okay, let me try and draw a similar drawing. So here is, it's not perfect, but I'm trying to do. If there was an exterior angle up here, this 82 that's sitting down here would be equal to this one up here. Does that make sense? So if there was an exterior angle up there. So what we'll do is let's use it in a question. And then once we do that, I think it will make a lot of sense. Okay, I just wanted to introduce the ideas to you.
That's okay, sir.
So let's go look at our first practice question. In fact, I'll even do this one with you. So this is how we would do it. I would say, and there's a couple of ways you can do it, but I would say this is the exterior angle of the cyclic quad. Here's the cyclic quad. Okay, so it's the one in like that. And the 100 is the exterior angle. Therefore, x must be equal to 100, like that. So x is 100, all good. Now, what about y? Well, there's a couple of ways you could do y, but I think that y and this 90 degree are interior opposite angles. And so together they must add up to 180. So y plus 90 must be 180. Therefore, y must be 90. So that's how I'm using the theorems. I'm using the exterior angle one to get x, and then I'm using the interior opposite one to get y. Now, the last one is z, and z is sitting over here. And there's actually two ways we can find z. The one way is to say, well, we know 100. We know that x was 100. Therefore, 100 plus z must be 180. And so 100 plus what gives you 180? 100 plus 80. So you could do it like that. Or you could say all the angles in a quadrilateral add up to 360, and then just take away all the angles that you know already. And that would get you there. So this is a typical type of question that you get with those types of stuff. I know I'm asking for, would I be wrong if I was to use angles on a straight line? No, completely fine. Now that I see it, you're quite right. You could get Z by saying angles on a straight line. And in fact, I think that's the easiest way to do it. I was just wanting to show you that you can use the theorems as well. Okay. Over to you guys. I want to know, what is X and Y? So I want you to work that out and pop it in the chat when you've done that. What is X and Y? Okay, I'm seeing Ayabonga, Masana, Emmanuel, Letabo, Kodisang, and you're all agreeing, and you're all agreeing because you're all right. So you're quite right. X is 88. Let me write this. X is 88, and Y is equal to 105. And we're basically using the exterior angle of a cyclic quad idea. So, yeah, as simple as that. And so, yeah, I like what I'm seeing in the chat, and I think I'm happy to move on for everyone. Okay, let's do this one over here as a little bit of a slightly harder one. So I want you to try and find me. It says here that PS is a diameter, and I want you to find me X, Y, and Z. And I'm going to give you a little bit more time to do this one because there's a little bit more work to be done. So over to everyone. Find me X, Y, and Z. So lots of people are saying they know what X is. And it looks to me like they're getting it right, because to me, it looks like PSRQ is a cyclic quad, which means 120 has a relationship with X. So I know what you're doing there. Looks, don't worry. Start by focusing on the relationship between 120 and X. What does that remind you of? Or what's special about PSRQ? So X, I agree, is equal to 120 degrees. If I was writing a reason, I would just say exterior angle cyclic quad. But again, we're not obsessing about that at this stage. We just want to know, we know where to go. And then Y, well, we did that review at the beginning of the lesson where we said, if you've got a diameter and you know that the diameter subtends an angle, or it builds an angle at the circumference, then it's going to be 90 degrees. So this one, so this angle Y is going to be 90 degrees. And if you're using full reasons, it would just be angle, or angle in a semicircle is the shorthand, angle in semicircle. Okay, so now we've got a bit of a problem. We know that this is 90, but we don't really know what's going on with Z. Has anybody got ideas about Z? Who would be willing to share their wisdom or their knowledge? Refente, let's go to you. Or Refente.
Hi,
How's it
Mr.
going?
Ed.
How are you?
I'm okay.
Tell
So,
me what you know about Z.
since Z is, you see there's this triangle PSQ, I think PQS.
Yeah. Yeah.
I know that the sum of interior angles of a triangle is equal to 180.
Yes.
So here over P, we have 120,
Yes.
and we have to use the, what do you call this? 180 minus 120.
Oh, angles on a straight line. Yes. Yes. Angles on a straight line gets you a second angle in the triangle. Okay, I see where you're going. So what do you do to get Z?
you're gonna say 180 minus 90 is equals to 30 degrees.
Yep. So
Yeah.
Z actually wasn't so bad. Well done. I think the insight was getting that extra angle inside the triangle. And then it seemed to be like it made a lot more sense. You had to see, even for me initially, I was like, I wonder how we're going to find Z. But then once you see that this is 60, it becomes that. So Sinosipo was asked, why is Y 90? So Sinosipo, there's the theorem that we covered, I think it was in lesson 2 or lesson 1, where it says if you have a diameter in a circle, so it has to go through the center, then an angle that you subtend, that you make at the circumference, will always be 90. It's called angle in a semicircle. And so we were using that idea. Okay. How did I get 60 on P? The way I got 60 was, this is an angle on a straight line, and we know that angles on a straight line, let me draw this is a straight line here. And we know the two angles together, 60 plus 120 must add to 180. And Paul, let's go to your question. And Paul, what is your question? Maybe your hand was just up. Okay. All right, everyone. I think it's time for a break. So let us stand on up. We are human. Our bodies need a break. We can't stay sitting the whole time. It just will not be good. So stand up. And make sure you've got a bit of space around you so that nobody is too close. And just start by swinging your arms nice and freely. Just let them hang and let them swing. Turn on your camera and just, yeah.
Please turn on your cameras, guys. Let's see your lovely faces.
And just swing your arms around nice and loose so that your body starts to go, oh, I'm not sitting. You might hear some clicking sounds.
Give your mind a break.
Oh, I'm hearing lots of clicking sounds. Second bit, small circles with your hand. So small circles. And then slightly bigger circles. So kind of your shoulder blades start to unroll a bit, and then big circles. Okay. And then
People in the chat are saying they look crusty, so they can't put on their cameras.
Okay, then what have we got left to do? I think what we need is a raised heart rate. And to raise our heart rate, guys, there's no, well, we could do running on the spot, but that's a bit much. So let's do jumping jacks. And I want to do 10 jumping jacks. So make sure you have space. And we start in 3, 2, 1, go. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I feel like, and maybe if you've got some water nearby, just have a sip of water to just, yeah. So the idea, you may think I'm just enjoying the fact that I have this power, but I promise that raising your heart rate, getting your blood pumping really does help you just sort of relax a little bit. And it's well worth the investment. So here is your sort of mystery question, brain break question. For the joy of being confused, let us look at it. A 300-foot train is traveling at 300 feet per minute and must travel through a 300-foot long tunnel. How long will it take the train to travel through the tunnel? That is today's brain break question for the joy of mystery and being confused. Pop your answers in the chat, and I want to see what everyone says. I'll start trying to draw a tunnel. I won the art prize in grade 1, but after that it was downhill, I'm afraid. So don't expect too much. Okay, there's my tunnel. And okay, my train is gonna look more like a truck or something. I don't know. That's my train. Okay, so this is not on the syllabus. This is just me finding questions that are, oh, some of you guys, sneaky. So we have a couple of different answers. We know the train is 300 feet long, and we know the tunnel is 300 feet long. And we know that it's traveling at 300 feet per minute. So some people have said 1 minute, some people have said 2 minutes, some people have said 300 feet per minute. What is the answer going to be? It is a bit confusing. Okay, so imagine you're a train and you get to the front of the tunnel. How long does it take for the front to get through the thing? Well, it's going at 300 feet per minute, so it takes 1 minute for the front to get to the other side. But how long does it take for the rear end of the tunnel or of the train? Well, it only gets to the start after a minute. And so it has to go a whole nother minute to get to the end. So the correct answer is 2 minutes. Okay, well done. Well done, well done. So that was sneaky because the train is as long as the tunnel. And so even though the front gets through after 1 minute, it only counts as being through after 2 minutes. The audience has spoken and they're like, yeah, well, I hope you got joyfully confused with that one. That was the, as opposed to what's the word like in math class when you're painfully confused. You're joyfully confused is different. You know, so yeah. I must remember that. That's actually a good one. So let us go back. You know, don't feel defeated. That was hard. I think I would have, if I didn't know that question, I probably would have also sat there and gone like, So let's do it. Let's do it. Okay, so we are going into a second round of questions. And let's start with these two. So find me answers for C, D, and X and Y. I want you to figure out answers and pop them in the chat for those ones. Okay, so lots of people are saying that C is 101, and I completely agree because I can see the exterior angle, and then C is just the interior opposite. And then for D and 96 are interior opposites, so they add to 180. So if I go 96 plus D, I get that, which makes me think that D must just be 180 minus 96, which is 84. So this should be 84. What about X and Y? Who would like to explain how they got X or how they got Y? I'm curious to know if anybody can share their thinking. I just want to know kind of what were you thinking, and the answer is, you know, it's not the most important. It's more about what process did you follow. Anyone willing to share their thinking? Yeah, let's go to Fateko. What were you thinking through when you did this?
So firstly, I can see that the exterior angle 92 is opposite x. So that makes x 92.
Yep, completely agree. X is 92. What about y?
The same thing, sir.
So what value do you get?
116.
Perfect. That was awesome. 116. Okay, you guys totally got this, or at least it looks to me like you've got this. And so I think it's time that I start mixing up the questions a bit. So let's go to question number 4. I want you to find me for question number 4, what is the value of D? Now, this is a little bit trickier, but if we help each other out by giving each other hints, maybe we can get there. But what's the value of D? And what information do we have to even help us? That's what I want to think about. Please send hints, guys. I agree. My brain hurts looking at number 4. Ish. Okay. Who's got a hint for us? Who can? I always say, like, what have you got in your toolkit? Like, when you look at number 4, what do you know for sure? Like, what do you know from looking at the drawing? What you know? It's a circle. There's this shape. It looks to me like it is a 4-sided shape. So I know it's a quadrilateral. What is this, a particular type of quadrilateral? Yenzi, what do you think?
So I think that 2C and C will have similar answers or half of each other. I don't know if I'm making sense. And
No, you
will either be equal or be half of each other.
Okay, so let's just focus. Did you say like the ones opposite each other are important in some way? Did I hear that correctly?
Yes.
Okay, what sort of relationship do D and 3D have? If you had to look at it visually. Aren't these opposite angles in a cyclic quad? I know that it's a weird cyclic quad, but the 4 points are on the circle. So I was thinking, aren't they opposite each other?
Oh, yes.
So tell me, what do you know about this statement, D plus 3D?
They are supplementary, which means they're equal to 180 degrees.
Perfect. Perfect. I think you've given a big hint now. So I'm going to go to someone else, but that was super awesome. Thank you. And Paul, what do you think we need to do next?
So I just think that we must add the D plus 3D should be equals to 180. So we just say 4D is equals to 180, then divide by 4 on both sides.
Yo, just like that. 45 degrees. Awesome. So this would be 45. And if you were working out, this would be 3 times 45, which would be 135. Yeah. So D must be equal to 45. Now, I want you guys to find me what is the value of C. What is the value of C? Well done, Paul. So using what you know about circles and cyclic quads, what is the value of C? A couple of students are saying C is 60. Would anybody be willing to explain how you get that? Who's willing to kind of just share how they got C? Tabogo, let's go to you.
Hi, sir.
Hey, how did you get to 60? How did you get there?
Because opposite sides are equal, I said 2C plus C is equal to 180, and then it's 3c and then divide both sides by 3, which is 60.
Oh, so it's actually quite similar to the previous one, huh? So it's just that you're dividing by 3, you get 60.
Yes.
Perfect. So then this would be 60, and this would be 2 times 60. That would make this one 120. Brilliant. Yeah, so that wasn't so bad once we got through the idea of what that was a cyclic quad. It felt like that was the key thing. Yeah. Okay. Ipileng, you have a question? Let's go to you. What's your question? While I'm waiting for that question, why don't you guys try and do number 5 for me? So I want you to do number 5, and number 5 is to find the angle H. Try and find the value of angle H using what you know about circles. Ipileng, any questions or you with us? Okay. Ipileng. Oh, I see like a bit of a background. Okay, maybe it's me. I don't know. So can everyone hear me? I think they can. Awesome. Okay, so I see a couple of answers flying in here, which I like. I like to see a bit of variation because there's a bit of competition or a bit of difference of opinion. Who would like to have a crack at explaining their answer? Because I see lots of different. I see 37s, 47s, 55s. Who would like to just give us some thinking as to how they went about doing this? Rafense, let's go to you.
I think the angle, the 106 angle projected at C.
Okay, so you talking about this one, yeah? What do you do with it?
I think it's equal to A.
I agree with you because it's the exterior angle. Perfect. Yeah.
And
now,
then we have those two sides are equal. You see
you spotted this. This seems important. What does this give you?
It means that H and the angle at B are equal.
So you know both of these are H. Yeah. Isosceles triangle. Yeah.
And then the sum of interior angles of a triangle is equal to 180.
So you're saying 2H plus 106 is 180. Yep. And then
it's going to be 2H is equal to 180 minus 106.
So that's 74. And what was your final answer?
Divide by 2 is, what did I get? Let me see. 37.
Yep. 37. Respect. That's a harder question, huh? Well done. Show who's boss. Okay. Let's see now. Let's do number 6. So I want everyone to do number 6. And to do number 6, you have to find what M is. So M is sitting over here. What is the value of M? Work that out for me. Oh, why do we divide by 2? So Nozi's asked, why do we divide by 2 in the previous question? So Nozi, if you think about this question 5, an important idea is that the angle up here and the angle down here are the same. So we say H plus 106 is 180. And then because H and H are like terms, we say 2H plus 106 is 180. So that's where the 2H comes from. And then we just followed the process. Does that help, Mozi? Let me know if that helps. And then I see a lot of students saying that they have got 118. So I'm guessing that because this is an isosceles triangle, that's 31. And then the next step is to find what this is, which is going to be 180 minus 31 minus 31, which is 118. So this one here is 118. But what is the relationship between D and M? It looks to me like M is the exterior angle, and then D is the interior opposite of the cyclic quad, a CDE, well, yeah, a CDEB. And so then M must be equal to 118. 162. Yes. Yeah, exactly. Awesome. Cool. Let's have a look at 7. You guys are doing so well. I'm just like, I'm loading you up, but you know, I believe in you. You've done very well. Try and find. Yeah.
Oh, sorry, Mr. Is there time to explain number 6 again?
There is, definitely. So while I explain number 6 again, those students who feel willing to, try and see if you can find me the value of E and F using whatever tools you have in your toolkit. So for those who would like another explanation of 6, let's just wipe everything out first and make sure you understand that M is sitting out here. Now, this angle over here, because of these single lines, these two are triangles in an isosceles, or they're angles in an isosceles triangle. And so this must be 31. And this is all because of these two lines that are saying it's equal. So now, if I want to find what this angle is, I simply need to go 180 minus 31 minus 31, and I get 118. So this angle is 118. The problem is, what has this got to do with the M down here? Well, what it's got to do is D is the interior angle and M is the exterior opposite. And so M will be 118. So I hope that helps a little bit. It feels to me like finding E first would be easier. But I'm not sure. Let's, maybe people do it in different ways. It feels to me like these two angles have some sort of relationship. I think E plus 4E must be equal to 180 because they're opposite angles in a cyclic quad, which we've discovered today always add up to 180. So we get that. Now, what is 180 divided by 5 going to be equal to? It feels to me like it should be 36. So this is 36. And then this down here, we don't have to work it out, but it would be just 4 times 36, which would be 144. Now, the last thing that we need to do is work out what F is. Now, I'm interested to know what people say F is. Maybe someone could come and share or defend their answer. I want to know what angle F is equal to. Some people are saying F is 144, but I'm remembering something from earlier in the lesson and also from previous lessons. we have to be careful about. So some people are saying 72. Some people are saying 144. Would anybody be willing to share their thinking about how they got their answer for F? Who feels like, let's go to Fatejo. What is your thinking for?
Okay, so first I'm gonna start by explaining why F is not 144.
Okay, go ahead.
If the angle at F is not on the circumference, therefore F and D cannot add up to 180.
Yep. That is such a good, that's so good, right? So I'll just say it again. Because F is not at the circumference, F and this can't add up to 180. What can they add up to?
So I forgot the theorem, but
Yeah.
F is double E.
Yeah. So it's the angle at the center is twice the angle at the circumference, or it's the theorem that says, here's your common arc, and you make the angle at the center, and it looks a bit like an arrowhead. And so the angle at the center is double the size of the angle at the circumference. So this is kind of an older theorem from where we're doing it. And so we would say that F is 36 times 2, or 72 degrees. And that is the correct answer. Awesome. Guys, I've really taken you now up to much harder types of questions. And next week, what we're going to do is we're going to start talking about theorems that have to do with tangents. So week 1 was theorems, centers, and the circles in the center. Week 2 was circles and cyclic quads. Okay, cyclic quads. And week 3 is going to be circles and tangents. So that's what you've got in store next week. And Lebo, if you could put the link to the quiz now, that would be awesome. And guys, I would say do it maybe like now, or do it after supper, or by latest tomorrow, because I know the quizzes are marked, I think, on Friday morning, or Thursday evening, Friday morning. So do it now while it's still fresh. And yeah, thank you for a lovely lesson. I really enjoyed teaching you. It was really nice, felt amazing, and I hope you learned a lot. So, and thank you to you, Lebo.
Always a pleasure, Mr. S.
Pleasure. So, Nazi, we didn't cover theorem 1 yet. I will maybe talk about that a little bit in the last lesson, but theorem 1, I was thinking that it's important, but not as important as the theorems I've covered. And because of our limited time, I really went straight for what I think are the most important theorems. So I didn't, theorem 1 is used, but not as much as the other one. So I'll briefly mention it at the end. Okay.
Mr. S, we're starting trigonometry after this section, right?
Yeah. So we're going straight into trig. So the week after, so after next week, we go straight into trigonometry. Yeah. So that's coming to a place near you. I know some of you guys have already started trig. So don't worry, we're coming there soon.
Yeah, there's someone saying they're writing on trig. So I think I would suggest they watch a previous lesson.
Yeah. No, I would totally agree. So remember, Watobe has even a lot of there's grade 10 trig. So you can go to a grade 10 class recording and look at trig if you really feel like, whoa. Otherwise, let me see if I can't just quickly go to the website for a second. Let me just pull it up. So we go live and we go find something here. And then let me share my screen. What are you seeing now, Lebo? Are you seeing my screen? Not yet.
Not yet, Mr. S. Yes, okay. I see it now.
Okay, so if we go to Watobe and we go to classes, and if we go to grade 11, so those are different types of trig. There's trigonometry general. So that was quite a long time ago, but there is definitely stuff there that could be helpful when we're really starting. And then also we had exam revision. Let's have a look. What did I do? Some lessons on trig. Yep, here we go. General trig. We look at average questions on general trig from the past exam and general trig stepping up. So there's some recordings there that are definitely helpful. And then also you could even look at some grade 10 trig, trigonometry 2D, trigonometry there. And yeah, so I would definitely say have a look at those, especially the summary lessons that from the old exam, that might be quite helpful. Okay,